The topic which we are trying to understand over here is revolution, or full rotation, or a complete circle, or a full circle. This is what we're trying to understand. So to understand that, we have a circle over here, a disk structure, with this being the center, right? And everything is rotating around this point. Okay. So we'll consider this as the reference point, and we'll consider that this this disk is moving in a clockwise direction. It's the same direction as the hand or minute hand or hour hand of the second hand of the clock rotates. That's why it's called as clockwise direction. So after some time, say it starts rotating, and after some time we see the line, right, reference line over here. We set to have, the wheel is set to have rotated, the disk is set to have rotated 90 degree. After some time, say the line is over here, the wheel is, or the disk is set to have rotated 180 degree. If we see it over here, it is rotated 270 degree. And if it comes back to the same point, it is said to have rotated 360 degree. And such one complete revolution is known as one revolution, a full circle, a complete turn, or a full cycle. Sorry, full rotation. Okay, so there are 3 to 4 names, but the main name is revolution. So you can visually see this, right? Here you can see that the wheel rotates from one end to the other end, and this is one complete revolution. Okay, so if you notice, it started from the red line and it ended on the red line, right? Now, what else we need to understand? We need to relate the revolution and the travel. Okay, so for that, let's consider a non-slippery surface. So this surface, it's no slippery. It does not slip. Things won't slip on that. So on that we see a vehicle. So obviously there is a wheel, right? And this wheel, say it is said to have rotated a lot. Okay, so this wheel has said to rotated a lot. What does it mean? Means the vehicle has traveled a lot. Is it not? If this wheel tells that, okay, I turned a lot from past so many hours, I've turned so many times. Means what? The distance traveled by this vehicle is a lot. Okay. Say the other wheel tells, some other vehicle's wheel tells, I didn't rotate that much. Right? What does it mean? Means the vehicle has not traveled that much. One more thing that we can tell is, so we spoke about distance traveled. One more thing that we can tell is, if a wheel tells, from past 1 minute, I've rotated thousands of times, right? This means that speed is a lot. If some other wheel tells that, past 10 minutes, I've rotated only, past minute, I've rotated only few times, then the speed is less. Okay. So we can relate revolution to distance and speed. Obviously, time as well. So if you can relate to speed and distance, even time can be related. Then, what is the mathematical aspect of all of this? So mathematical relationship between the revolution and the distance covered. To understand, let's go back to the video. So we can see that the wheel started rotating from this point and it ends over there, right? So let's come back to the board. So we saw that the wheel started rotating at 50 unit point and it ended at 220-ish unit approximately. Okay, so it started at 50 unit and it ended at 220 unit. So what is the distance traveled? Distance traveled is 220 minus 50, that is 170 unit, right? That's what we can tell. Is it not? So how is this distance related to the circle? The distance traveled when the wheel or the disc goes one revolution, it will be equal to the circumference of the circle. Okay, so basically this length should be equal to the circumference of the circle. Okay, so do you believe me that this length is equal to circumference of the circle? If you're told no, then it's a good thing, because in the next section we are going to visually prove it that it's equal to circumference of the circle. So we know that circumference of the circle is nothing but 2 pi into the radius of the circle. So I'm trying to find the radius of the circle visually. So it's a visual proof. So it's the same circle, that though you can believe. I'm not that. No, I'm lazy to make one more circle and all that. It's the same circle. So you can believe my laziness, right? Now, I have drawn a radius, and along the radius, I've drawn two perpendicular lines. So obviously, this is a parallelogram. So if this is radius and this length is also, which length? This length is also equal to the radius of the circle. Okay. So approximately how much is this? Around 220, 190 is 30. 30 minus 1, 1.5, 1.5, around 27. Right, 28, 27. So this is around 27-ish unit. Okay. So now let's calculate the circumference of this circle. So circumference of the circle is given by 2 pi r. That is 2 into, I'll take 3.14 into 27. Right. So let's make use of the calculator. And this is approximately, you can see, I didn't cheat, 170-ish unit. So it makes sense. Right. What we did was right. What we concluded was right. That is, if a wheel rotates one revolution, the distance it travels on a non-slippery surface is equal to circumference of the circle, right? Okay. So to summarize, a revolution is nothing but a complete revolution is nothing but a full rotation is nothing but a disc or a wheel going one complete round, making a 360 degree. Okay. The important conclusion that we saw was, depending on the number of revolution, right, we can talk about the distance. So one thing which we are sure of is, for one complete revolution, the distance traveled is 2 pi r unit. Okay. So depending on r, it will be in centimeter, meter, whatever it is. So this is the scenario. Right. This is an important conclusion that you need to remember. The whole video was to come to this conclusion. Okay. So one complete revolution gives us a length of 2 pi r, where r is the radius of the disk. Right. So we can call this as r.